Hello friends, this video on Kinetic Theory Part 5 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from Part 1 to 4 before going ahead with Part 5. Now let us start the topic on behavior of gases. So how do we think gases behave? Gases at low pressures and high temperature, much above that at which they liquefy or solidify, approximately satisfy a relation between their pressure, temperature and volume. So it says that normally any gas which is at low pressure and high temperature. So, see, it clearly specifies that it is much above that at which they liquefy or solidify, because now we are talking only about gases. So, we don't want to talk about the temperature range where the gas either converts into a liquid or it solidifies, right? So, we are talking purely of the gaseous state. So, it says gases at low pressure and high temperature, it always satisfies a relation between the pressure, temperature and volume. So what is that relation? It is PV is equal to KT, that is the product of pressure and volume is equal to a constant K multiplied by the temperature T. So this is a universal relation which is satisfied by all gases at low pressures and high temperature. What is K? K is a constant for a given sample of gas. Now this K varies with the volume of the gas. So this is basically a constant for a particular volume of gas. So if you increase the volume of the gas or if you change the volume of the gas, then the value of this constant will also change. So what is this K basically? This K is nothing but N into KB. What is N? N is the number of molecules. And what is KB? KB is nothing but Boltzmann constant. So this is how we define this constant K. Now what is this Boltzmann constant? It is a constant which is same for all gases. The value of Boltzmann constant will never change. So from the equation we can write PV is equal to N into KB into T. Well, now as we said that KB, that is Boltzmann constant, is same for all gases. So we can say that PV by NT is equal to constant, because this KB is same for all gases. So that means if we have two gases, let us suppose we have two gases. One of them is defined by P1, V1, T1 and the other one is defined by P2, V2, T2. That means let us suppose one gas has a pressure of P1, volume of V1 and at temperature T1, and the other one with pressure P2, volume V2 and at a temperature T2. So we can say let these two gases be any gases, but we can always say that P1 V1 divided by N1 T1 will be equal to P2 V2 divided by N2 T2. So this relation will be true universally, irrespective of whatever gas it may be, but this relation will be satisfied by all gases at low pressure and high temperature. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.